All right. So right here we were. What was I doing? Let me let's check to see my commits. Oh, this is last week. Oh, that's just some test. I did it in the start of last stream. Okay, let's go to my terminal. Okay, what was my, so let's see, I'm gonna reverse search for TSC, right? TypeScript. Okay, that compiled. Let's look at our net.ts. Model.summary. Okay. So now that we, so if that compiled TSC, that means we have net.js. So we have to just do a node net.js. 184 total parameters. Wait, what? I know this. Wait, what? Okay, okay, so like, where's the convolutional layers? Where's the convolutional layers? Just input dense, dense, dense. I mean, we know that like two of them are like, what the hell? We know two dents are like the outputs. Like one is for the 10H, like one is for the value and one is for the policy, and then one is after we flatten them, right? But then there should be more layers for the before ones. Okay, let's see what's going on. So we have our input. Okay, that looks good. Then we have convolutional layer 1, 2, 3. Then we flatten it. Then we dense it. And then policy value model set. That looks good. Okay, input. Conv1 applies it to input. Conv2 applies to conv1. Conv3 applies to conv2. Flatten applies to conv3. Oh, okay, so this has to be applied to the flat. Okay, now let's see it. Let's compile it. And then let's run it. Okay, there we go. 1472. Okay, that looks good. Our input parameter 0, sure, it's input. Wait, okay. Is this a problem? Okay, so our convolutional filter, like the kernel is 3 by 3, right? So like, after we apply it, right, like, it like, I guess it does it by 2. So like 6 becomes 4, 7 becomes 5, right? So like, after doing it, like, that's how it kind of changes. Then 4 becomes 2, and then 5 becomes 3. 8 are just a number of filters. Like the new channels, I guess. Because it's like, okay, and then, okay, so this 2 becoming 0, I mean, that doesn't, okay. I'll just delete the layer, right? Let's just delete the layer. So we deleted conv3, and then we're just going to make this a conv2. And let's look, 1472 parameters. Now let's run it again. Okay, 1656. Because now the output shape's like 238, and then yeah. So as we can see here, right, after doing flattening, we just get like 0. By the way, all these first nulls are like kind of like you can ignore them. I think they're like the batch, like the number of samples. Like it's just it's a null. Like the first dimension's always null. It's just like how many training samples or like pieces of like how many, like it's like the input size, I think. anyways, who cares? The point is that like here it becomes 0, right? Like we flatten it to 0, which is not good, right? Whereas here after flattening we get 48, and then from 48 you get 16, right? Because like, okay, and from 16 we can extract 7 and 1 for policy and value heads. Okay, that looks good. Get status. Let's just save everything. So get diff. Let's see the changes I made. We deleted one conv layer right here, then we flattened it. Applies to the old conv layer. So these two do the deletion, and this one fixes the it fixes the case where we're skipping the conv layers. We have to apply to flat. Okay, yeah, that looks good. Get status. Get commit work. Let's call this like initial CNN convolutional neural network for Connect 4, or just initial CNN or architecture. I don't know if I spelled that correctly. Get status. Get push. Okay, I'm just gonna see it here. Sorry about that. Recent browsing. Okay, anyways, what am I doing? What am I doing? I have too many tabs open. Help. Commits. Just an architecture. So I just saw this new commit just adds a file, right? We just yep, this just defines our model, right? Okay, this looks good. This looks quite good. Yep. Okay, now let's look at the bigger picture, right? Like we have this Connect 4 game right here. We can wait, what? What is going on? Okay, so this is what? Something like that. Oh, it's the run.sh. Okay. Game over, you won. So right now the bot is doing random moves, right? I should delete this console.log. What is doing that here? Console.log. Admin. Okay, fine. Game.js. That's 43. Get status. Wait, what? Oh yeah, I have to do a TS. The JS is actually ignored. What is drawing it? Maybe drawer actually. Wait. Drawer.ts. Yep, there we go. That will delete all those these obnoxious print statements. Okay, so now that we have a neural network, we want the bot to actually like use it. So like yeah, let's just status delete that comment. Game.ts, right? Let's just search for bot. Transition to bot turn. Yep, here we go. These are the lines. Create the bot's neural network for a move. For now, random. Extract onto a bot.ts file. Okay, so let's create a new bot.ts file. And can we like kind of let's just look at move.ts for reference. Okay, so export class bot. Okay, so now we're gonna create like a new bot.ts file. Like instead of having all the code in game.ts, like which randomly selects a move, we need to actually extract it. Okay, so like what does the bot need to know, right? Like what is the shape of the class? Like what methods should it have? What members, like what fields, what data does it need to know? Well, it needs to know if it's player 1 or 2, right? Something like this. Let's just call it like is what is P1 bot. Okay, so like it needs to know if it's player 1 or 2. What else does it need to know? What else does it have to have? Well, we can populate this in the constructor, can't we? Okay, something like that. Okay. I just want to see how GameState.ts looks again. Something like this, right? Let's copy that. Okay, so now for the almighty actual thing, right? Let's actually look at GameState.ts. Was it transition to bot? Transition to bot turn, something like that. Okay, bot turn. What? Bot? Oh, I'm in GameState. I'm not in game, sorry. What am I doing? Game.ts. Okay. So to do, let's query our bot's neural network for a move. For now, just random, later extract onto a bot.ts file. Dummy bot move. New move. Okay. So the main thing is this line right here. Right? The move takes an I am not P1. So what the bot needs to do is, given the game state and its player, if it's P1 or not, like it has a boolean for like whose turn it is to make a move. Then what the bot can do is it basically gets get move. It just like gives a move, and its input is the game state, right? And then what it returns is it returns a move. That looks good, right? Get move. Okay, so then so now we should actually instantiate the bot here, right? Let's just copy this line right there. Okay. Okay, so then we do, first of all, we have to actually import game state and move, so let's just do that. Let's copy and paste that from here. Okay, something like this. And then this move is P1 bot, right? Okay, this looks good. So I have to actually create a bot, right? So then okay, so then this thing, it takes an IMP1. So let's look at where that's like the thing we care about, right? Start game. So in start game, I think we should create the bot here. Okay. Bot equals new bot, and then the bot is basically this thing right here, right? As we saw earlier, the not of the whatever the human is. And outside, like, we have to define declare bot, right? Let's just for now, I'll just pass and false. I mean, well, why not? I mean, as we all know, like, later it does get changed. So in here, it gets changed, right? Let's go back to transition to bot turn. So then here, instead of this thing right here, what we can do is sorry about that. Let's just copy this here. Let the bot move equals to bot dot, what's the thing called? Bot dot get move. And this thing annoys me. Can I just like have it be I have to also import the bot, right? I wonder if that'll cause any errors. Okay, bot.ts, line 12 and game line 105. Correct, it is this dot is p1 bot. Then line 105, right? Yes, dot get move, and then we have to apply, you have to give it the game state, right? Now let me just make sure game state is where's game state defined? New game state. Okay, that looks good. Okay, nice, it compiles. Very nice. Status. Let's do a get diff. See, let me just clear everything. Then do a get diff. Okay, import bot. We create an undefined bot. Then when we start the game, we instantiate it. And then what we do is we just query like this bot, and then we just okay, so just extracting the function onto a new bot class. Now one thing I'll do is the to-do comments too, right? Let's so this one's addressed, and this one, let's kind of delete that there, and let's paste it here. Okay, that looks good. Good status. Okay, let's run everything. I'm just gonna test it out to like see if make sure there's no changes I can play a game with against the bot. Wait, I'll go second. Okay, bot move there. I'm gonna leave the hello there. I kind of like it. Oh, let's see if I can have the bot win. Yep, game over, the bot won. I mean, one thing I could do is like have it highlight a different color, show it's like point out what wins, or draw a line or something, but I'm too lazy. I mean, it's pretty obvious like what just happened. Okay, that looks good. Yeah, let's just disable progress here. Get commit extract a random bot move to a new bot file. It's a new bot class. Get status. Get push. Okay, yeah, it's nice that like this bot has its own class, because now in this bot class we're gonna like integrate the neural network. That's the next step. Commits, go back, refresh. Create a new bot. So in this constructor here, I guess that might be a good point to like do the neural network stuff, right? We have our net.ts, and then we can kind of do that. So here, okay, we just uncommented the print statement. Okay, so now all the work is going to be in this class right here, namely how to actually do get move. Okay, that's actually good progress right now. That is doesn't seem like much, but it's like kind of nice and logical. We're just kind of doing all our work inside here. Okay. So here's the actual work. Let's query our bot's neural network. So you have to get a neural network, right? Okay, in fact, all this, I might even delete net.ts and actually like put it inside the bot. Right. Okay. Now let's see how from TensorFlow.js. I mean, I know I did it right. I know we have a, what is it called? Test, right? Right. We test.ts. Like here's how it actually like. No, this is in the browser. Okay, let me just run it again. Let me see the JS output. Require TensorFlow node GPU, right? Okay, yeah. I know it was supposed to give you 9, I think, right? Right. Okay, so then this is how we actually use the network, right? So like to train it, we do model.fit. And then so .then, so it returns a promise. And then once it's done, then only then we can predict it. So this is async, but can we make it synchronous? Synchronous. Add agent. Fit is an async function. So wait all the way up to the top to get it working. Yeah, I mean, yeah, so like we have to fit and then we have to predict. But I want both to be like synchronous. Wait, no. What am I talking about? The model.fit is to train it, but that would be like that's separate. Like model.fit to train the network is like that's Monte Carlo, that's alpha 0. Like I'll be running alpha 0 separate, and then like all we care about is model.predict. Right? Yeah, okay, TFJS model predict synchronous. Yeah, like the model.fit is I mean like what like that's to train the network, but like right now we're assuming like when we're actually using the network, we're assuming it's already trained. Right? Synchronously returned. Okay, let's just go back to like an example. Just examples. Was in layers, save and load models. Use a pre-made model. Yes. Okay, let's pretend that we already have it, right? Overview. Okay. This is just training. Predicting new data. So is this synchronous or not? That's what I need to know. Okay, so they have async. That means this one's probably sync, right? Okay. So configs optional inputs. Okay. This is good. This is good. This is very good. Right. Okay. So we want our let's open up test.ts and let's open up net.ts. And for actually, okay, fine. And let's open up bot.ts. Status. Did I make any changes? No, I did not. And let's open up game.ts. Let's open up everything. Actually, for good measure, let's also open up a gamestate.ts. Actually, I think gamestate.ts is actually what we need. Okay, so then this is what we have, and let's compare it to this, right? We want to do a model.predict, and it takes in this case, we just do like the tensor, tensor 2D of just 5, which is one input and it's one dimension. What's tensor? So model.predict, this whole thing gives us a tensor. We cast it as a tensor, and then we do .print. I remember I had to stick that in because like there were some TypeScript errors going on. Because it could be maybe it was a tensor or symbolic tensor. It could be like a tensor or an array of tensors or something. I don't know. But the point is this works. Okay. Okay, so let's do something similar to this, right? Let's actually create like a class. Let's export a class, which would be let's add some space. Oh, what am I doing? Sorry. Okay, let's just okay, so let's create a class bot, right? Or sorry, this is net. This is a class neural net. This is our neural net, right? So what we want to do is okay, let me think. Wait, no. What am I doing? Let's undo everything. Let's undo everything. Okay, back to what I was doing. Okay, so that's the test. That's like that just shows you how to do the prediction. And here's architecture of our net. Let's actually forget net. Actually, let's just pass into the bot like the trained model, right? And to be honest, I'm not sure what the type is. What is the type of model? Graph model, layers model, sequential. Wait, hang on. In functional, I definitely saw something. Let's duplicate that. Go back. Models, models and layers. Models and layers. The functional model, right? So this creates a layers model. So that's the type, layers model. So this model is a, is a layers model. Let's copy that there, the TensorFlow stuff, right? So it'd be tf.layers model, right? tf.layers model. tf.layers model. And then model something. So that looks good. And then here we have to model using model dot predict. So we'll need to pass in we'll need to pass in we'll need to convert the game state into a tensor. In fact, for training, like I think, yeah, that's an idea. Okay, so like we have like this net.ts, right? Net.ts right here. Like this is like defining the model. I can create like another function which like kind of like, let's call this like a net utils actually. This could be net utils.ts or actually net.ts. So like what this net.ts we can do is we can have a bunch of like nice kind of helper functions, like kind of utility, like just net. It'll have like some utility functions which we can use to like kind of convert the game state to the tensor, the input, right? Okay, but right now, like, how do we actually pass in the model, right? Like, we need a model. Like, we need this model. Like, it has to be an actual thing. And then, like I said that once we train it, we get it, right? Like, we do a bunch of training. But, like, when we instantiate the model, initially the weights and biases, all the parameters are randomized. So, like, this whole dummy.bot move, like, we have to kind of replace this with actually doing model.predict. We have to somehow like parse in the model. Okay, so then right here, right, save and load models. Okay, let's actually do that right there. Save a TF. What's a TF model again? Page not found. Well, that's pretty sad. Model.save. Okay, this is really dumb. TF.layers model.save. Okay. Save. Okay, this is local storage. This is index. I care about like files. Yes, files. Or wait. Actually, let's just actually look at this. Model.save. Topology and weights of model. This is a file displaying architecture of a model. It contains references to model's weights stored externally. Okay, so this is the graph network. That's the weights. Okay, yeah, I've seen that before. Results. Here we go. Loading. Okay, let's actually save it for now. Well, let's just save it, shall we? All right. Model that saves in file, path to my model. Let's just call it just my model, right? File, model, something like that. .ts. Okay. Okay, I see the problem. Okay. Alright, fine if you insist. Cause is there synchronous save? Well, who cares? I'll just accept it. Let's call this. Let's give it async. Async function create. Let's call it create model. Actually, okay, to do, check if model exists already, right? Only if it doesn't exist, create a new one. We don't want to like delete our old model, right? Let's delete this one. Something like that, right? So we do it here. Well, the summary looked good, I think. So we just save it there, right? Oh wait, model.save file model. Wait, no, we have to compile it, right? Wait, that's not enough. Train models, right? Or wait. Training it. Okay, let me just look at this. So we're creating a sequential model input shape. It takes in 784 and then a hidden layer of 32. 784 and then to 32, and then from there we get 10. 74, 32, 32, 10, 10. Wait, I don't understand this. 4 wits? There's so many wits. Whatever. Training, you have to define. Okay, but I have to worry about this stuff like when I'm actually gonna train. Also, how do I give 2 loss functions? Cause like, again, like our neural network has like the loss functions has 2 things, like 2 different heads, the value head and then the policy head, and like the loss function is like both, right? I want 2 things here in functional model multiple loss functions. No, this is not TF-JS. Just put that in quotes. Again, I don't think I need this right now. Two loss functions. Custom loss function. Okay, so you can do a custom loss function, like kind of do a custom. Okay, let me see how this code does it, right? The code here. Okay, so it passes in a whole list. Actually, let me go back to the API, right? The docs. Where are they? Where are the docs? Model.train, right? Or compile. Loss. Okay, it can be an array too. Function or the model has multiple outputs. You can use different loss. Okay, let's go back here. There's this file. I have lots of tabs. I must delete some tabs. Let's delete the whiteboard. Delete this tab. Delete that. Delete that. Okay, how did they do the compiling the net? Refresh that. Is this really all the file? Is this it? 32 lines. Okay, so in their initialization, so everything they're doing right here is basically what I'm doing right here. But then before saving it, they compile it. They pass in 2 losses cross. I mean, they pass it like first the policy and then the value, like corresponding to that and that. as like the outputs. So like, does that mean that the outputs and the loss like the order like does that mean that the outputs and the loss function like their orderings match each other? I mean, I want to see some documentation for that, right? Like, what if there's multiple loss functions? Okay. TensorFlow.js model compile two loss functions. Look. It has to be JS. Let me see if there's an example of this, right? Because I know there are a bunch of examples. Well, let's look at some examples, shall we? Just duplicate this. Functional. No, this is Python. Exactly, this is what I want to do. Yes, this would be perfect, right? That's a sequential. Yes, exactly. Complex graph topologies. Two outputs. This is almost exactly what I'm doing. That's softmax. Sigmoid's okay, except mine is just a single number. Oh yeah, this is a single number. Sigmoid. Mine's ReLU? No, mine's 10H. Mine is 10H output from between -1 and 1, 10H. Yeah, this is actually exactly what I'm trying to do. Priority prediction, which is the policy. That's that's a classification. Softmax, kind of like the policy. So binary, I guess. And then that's categorical. So I'm gonna probably have categorical cross entropy and the mine will be least squares or mean squared error, MSE, right? Okay, yeah, that looks good. Okay, train. I think it's categorical cross entropy. Yeah, exactly, one hot. Okay, I think that's correct. Let's look at the examples again. So many tabs. No, this is just I'll save this. I'll save this tab. It's a pretty nice tab. So now here the loss would be 2 losses, right? And then MSC means let me see what the let me just look at how oh yeah, oh wait, no, let's just reverse the V test. Yeah, something like that, right? So what's the loss function? Mean square error. Okay, exactly. That's the loss function there. Let's copy that. Here so I'm putting like the so like these are the 2 losses, right? The first loss is for categorical cross entropy, which is like the softmax, which corresponds to the policy output, and MSE mean square error corresponds to value output, right? So like policy output is the first one, and then value output is the second one. So then like value output, mean square error, policy output, categorical cross entropy, right? That looks good. Metrics, I'll leave that as SGD or Atom. Whatever, I'll just leave SGD. Status, get diff. Not too much space. Let's just clear everything. Get diff. Okay, so TF layers model. Okay. Okay, so right now, like the constructor changed, so TypeScript's gonna fail, but I'm just gonna call just TSC only on net.ts to see if like these lines didn't mess anything up, right? Nice. Okay, that's good. So these did not mess anything up. In fact, I'm just gonna run it, right? Just to like look at to see if we've saved the file. Oh, we never actually invoked create model. Okay, I see the problem. to actually create the model. So it's trying, so like when we're saving this thing, it's trying to create a new directory called model. So it's called, but like it's not letting Node do it. Oh, well, maybe I have to make a relative path. Current directory, right? No, that's the thing. It should not be like, this is like the root path. Never respects the TF-JS. It always defaults to its general TensorFlow. They only have 2 dashes? Like HTTP and then like 2 forward slashes. Oh no, not that. Okay, this worked. So now we can see model, which is the folder, right? Let's actually cd it. Oh, is this ls model? Right, so like you have a model.json and a waste up. And okay, actually let's just see how this looks like. model. Right, topology, so it's like a graph, right? Layers, input, you see conv 2D, you see kernel size 3x3, padding, whatever, all this stuff. So this basically defines the shape of the graph, right? Like when we do model.summary, then we have some like dummy weights in the beginning, I believe. Well, this is our weights. Okay, so we have our model. Status, get diff, get status. Let's just add model, this whole directory model to our get ignore, right? Let's just do that. Get ignore. Or actually no, it's not too bad. Actually, we can save it. Okay. All right, that's very nice. Now so now we can save our model. And now we have to actually load our model, right? Now we have to actually load it. So right now we've just like saved a dummy model. Get diff. Let me see our difference. So here we go. We actually pass into the bot the actual like layers model, and then okay, and then actually we've actually not tested this yet. This untested, because I've only been like doing it for net. Okay. Get status. Just get add all. Good point to commit, or actually I'll leave it staged. Okay, so now yes. Okay, so that's a create model. Now what we need to do is we should have a function that loads the model, right? In fact, actually, now that we created it, let me just comment it out so I don't create it again. I just like created it for now. Save and load model. I see it's in this tab. So this is save, and now loading it is load layers model, like that, right? Simple. Yeah, 2 forward slashes. Okay, yeah, that is correct. And this is an async operation. Okay, let's copy that here. And then when I'm instantiating the bot, right, let's search for new bot. What? Game.ts? New bot, right? I have to pass it in the model. And the path is just path to the model.json. Wait, what? Model.json file itself. Okay. Yeah, exactly. Whereas when saying specify the folder. Okay, so then this file path is this becomes the this becomes a dot slash model slash model.json. Is that correct? Yep, model.json, correct. Okay. And start game has to be an async function then. Okay, does that look good? Actually, what I can do here, that is a tf.layers model. Actually, let me just actually try to run everything, see if it works. What? What is this AW? What? Get diff game.ts. Okay. I see. I think I see. Yeah, this is only for this is for yeah. I have to delete that. I have to delete that one. Yeah. Okay. That makes sense. Let me just take this whole thing. Oh, no, sorry. Oh, no. Let me just do this right. How does the client side use it? I mean, I did use it, right? Sorry about that. Let me just quit. We have test.html, right? Oh, I see this. It used just deliver. Browserify. Bundle tf.js. tf.js. and delete the no GPU part. It worked. Yeah, because I mean you need to have this package installed, right? So like, yeah, that's the idea. Get diff. Okay, so we just await it. We just await that. Okay. Just run it again. Wait. No, this won't work. No, this model right now, right? This model is like it's like in the server. Like it's not like no, like this has to like the actual bot. No, the actual bot should be a no. The actual bot should like be a like browser, like local storage or IndexedDB or something, right? Because like this whole like native file system, like no, this is wrong. Like we have to serve this model somehow, right? We have to put it inside like when it's loading. It can't load from the it cannot load from the file system, right? We have to like load it from here or there. Storage. Okay, so like deploy tf.js model. Build your model. What? Just run a bunch of scripts and you're done. Okay, there's an example. Let's see the code. Main.js. I want to see the word load, right? What? Wait, no, this is server side, and yeah, you need client side. What? So you've created a custom machine learning model with TensorFlow.js, but now you need to host it somewhere to use on a website of your choice. 3 minutes for hosting. Web page. Deploy wallet website. Okay, create your TensorFlow.js web page. Okay, so it doesn't bundle it. It just like does it from there. My model.low layers model. Oh wait. What? TF load layers model. Yeah, the load layers model should start with local storage or IndexedDB, right? You can't just do this. What? Wait, what? Oh. Oh, is that what it's doing? Is this what it's doing? Oh. Okay, yeah, then it might be okay. Then it might be okay. Let me look at the networks tab. I mean, I ran it, right? I ran it, so it's compiled, right? So it's all compiled. Now, connect 4, right? Go to networks tab. Let me do that. Start game. No requests. Console error. Fetch. What? Model. Well, would you look at that? Okay, so I just have to do this, right? Connect 4, model, JSON. What was the error? Cross. Load layers model. HTTP. Relative URL. What? Oh, this looks nice. But how did, like, okay, that's a nice thing to have, but like, where does this come from? I mean, to be honest, I don't even care right now. Like, I really don't care. I mean, that's nice to know, but I'm just going to, just going to directly hard code this, to be honest. I'm just gonna straight up copy that. What? That. Too many tabs open. Where I was just there. Okay, I'll just do this then. Okay, I don't get how this does it. Let me just try what they're doing. Right? Just like that. That's it. Just that. Compiled. Okay. Relative path. Current directory. Okay, so it has the right URL. It's trying to load that. But what? Someone played it today? January 6th, right? $1,200. Could be the same person, 2 tabs. Yeah, many people get frustrated by wins and just quit. Oh, 2 different. Could be an actual game, or not. Yeah, typically people get really frustrated when they come on, collide, hit each other, play the game. Okay, he's trying to get to the king, so he seems to have some understanding, maybe. Nice. Alright. Okay, I'm getting bored just watching. Yeah, what is Golduin doing? Counterattack, maybe? Run away? Yes, you're showing some signs of self-preservation instinct. A bit of skirmish going on here. Oh, king v king. Yeah, I don't know why there's like the action should be happening here. I mean, it's nice that people are like testing out game mechanics, like just launching, flicking coins. I mean, just come on. Good. Oh, I want silver to win already. Yes, yes, finish it. Okay, good. Okay, so someone did play recently. That's nice. Anyways, what was I doing? Yeah, disallows. Okay, for now I'm just gonna stop, and yeah, for